is going to look just like this. In other words, I'm going to draw some random shape. So for this particular set of problems, we're going to be using that shape that looks like a triangle and an M.
Graph practice 2?
Yep, we're doing graph practice 2 because we are getting ready for a quiz. So here's, I'm going to go ahead and draw my standard picture, which is that, and then so I'm being very careful to get things all right. So there's my original shape. All right, everybody with me? We're on, I hope you have out graph practice 2. Now, we are limited by the size of the graph, so we just kind of have to work with it. And if they get too big and go off the page, that's fine. We'll just work with what we've got. And I say that because I think the very first one is going to go off the page. What does this number right here do? When you put a number on X, what does that do? That Malcolm's going like this. He's exactly right. This number divides the width. Now, gang, tomorrow on the quiz, you're going to have a different shape. You're going to have a different number here. What you've got to remember is a number in that position, look where it is, divides the width. Now in this case, we're dividing by a half, which is the same as timesing by 2. So you are going to draw that exact picture, but everything is going to be twice as wide. So, how wide is the original triangle? 4. How deep is the original triangle? 2. So now you're going to come over here and you're going to draw one that's still too deep, but now it is 1, 2, 3, 4, 5, 6, 7, 8 wide. So that triangle, 1, 2, 3, 4, is now going to be 8 wide. And so, yeah, if it goes off the page, it goes off the page. Don't panic about it. Just draw as much of it as you can. Now, what about the M? He's 1, 2, 3, 4, 5, 6 wide right now. Right? So he's going to be
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 wide. Do your best. Now, I know my first point's here and my last point's here. Now, right in the middle, if you're confused, look, to get that first peak, you went over 2 and up 3, right? So you're going over 4 and up 3. So over 4 and up 3. And then this one, this dot, is over 3 up 2. So he's going to be over 6 up 2. And likewise with the next peak. And there is your stretched out M. Everything is twice as far over as it was.
How would you know to do that on the test?
Because the problem's going to say something like this. The problem tells you. If there's a 1/2 there, that means you're dividing the width by a half, which is the same as timesing it by 2. So it's going to be twice as wide. You do whatever the problem tells you. Okay, so a coefficient on x divides the width. That's what you got to remember. So if we had something like this, that would mean the width is getting divided by 3. So it would be, everything would be a third as wide as it was. Okay, next problem. What's happening in this one? That took about all the room. Let's see, what's happening in this one? Actually, 2 things are happening. What does this negative out here do? This is going to be upside down. And that is going to go up 1. So we're going to be upside down and up 1. Now, I do this in 2 steps. Some of you can do it in 1, and that's fine. If you're going to be a 2-step person like me, you might want to bring a colored pencil or a highlighter or something so that we know what your final answer is. So, we go in the order of operations. We do multiplication first. So this is like timesing by -1. So we're going to go upside down first. So I'm going to take the picture from over here and I'm going to turn it upside down. So the triangle is going to go up instead of down. And the M is going to go down instead of up. Here we go. So I'm not done. I'm not done. I've tipped it upside down. So if you're having trouble, remember, if in the original you went over 2 and up 3, you're going to go over 2 and down 3. You're just going the opposite direction vertically. Up instead of down, or down instead of up. Now, I'm going to pick it up 1. Every point is going to go up just 1. So there's my triangle. And there's my M. So the blue thing will be the answer to the question. What about 3? What's happening in problem 3? What? Left 1. It's going left 1. That's all, just left 1. So we're going to take the original picture. Always go back to the original. And you're going to pick every point up and go left 1. So your triangle is going to be shifted over 1 unit this way, and so is your M. So if your original M ended at 1, 2, 3, 4, 5, 6, this M is going to end at 5, right? Because it's shifted this way 1 unit. Everybody okay with that? Everyone came in here so excited and enthusiastic, and I managed to kill that, haven't I? Nothing like some good old graph transformations to get you going on a Monday. Here we go. Y equals f of -x. All right. What happens when you put the negative in here? We already talked about a negative outside. What does a negative inside do? Now, seems going like this. It's left and right. It's across Y. So what that means is your picture flip-flops this way. So if it was originally on the left, you're going to have that exact thing now drawn on the right. So that triangle is going to be over here. Just flipped over to here. And similarly, the M is going to be over here. And that's all we're doing. We're just flipping it across the Y-axis. Blake, you got it?
Yeah.
Okay. So what was that? That was 4, 5. Oh, okay, now this is like pretty new stuff. We just talked about this last time. Who remembers what we do when we have the absolute value of the whole picture? We have the absolute value of the whole picture. Who remembers what that does? Bottoms up. That's exactly right, Mikey. Just everything on the top is going to stay put. So in my original picture, the M is going to not change a bit. The M is going to stay right there because it is already above. Anything above just stays there. But if you are below, you get folded up. So the triangle is going to come up. So that is the picture. If you have the absolute value of the whole thing, absolute value of the whole thing, if it's up, yeah, that's right, bottoms up. If it's up, it stays up. If it's on the bottom, it comes up. Okay? Everything's on top with the absolute value of the whole thing. Now, the next one says the absolute value of just X. Now, these are different problems, so you got to keep them straight. Does anybody remember what we do when we have the absolute value of just X?
Right side.
Copy down the right side. So wait, let me catch up. So I'm going to copy down the right side exactly as it is. So that's the M. There's the right side. I don't care if it's up or down. I copy it exactly as it is. The right side gets copied exactly as it is. Then what? Do it on the other side. So we have exactly the same picture on the other side. Now you might be saying to yourself, well, Mrs. Ford, where'd the triangle go? It's gone. The original left side of the picture is gone, and the right side replaces it. So if we have absolute value of the whole thing, it's bottoms up. If we have absolute value of just X, it's draw the right side, and then flip it over to the left. Okay, last one, we'll have the front side done. What's the last one? What's going to happen there in number 7? Mr. Day?
It'll be the mirror image, but down.
Exactly. So I'm going to cheat a little bit because I'm at the board and can do that. But I'm just going to take this picture that I already drew and move it down 1. So the black is the answer to number 6, and the purple is going to be the answer to number 7. So I'm using the same basic picture. Because putting the -1 on the problem simply takes whatever you had to start with, in this case f of absolute value, and move it down 1. So black is number 6, purple is number 7. Does that make sense to you? Would you turn it over? We're not going to do all of these on the back side. And the quiz tomorrow will be only one side. This is just extra practice here. Are there any on there that look like you might want to do them? We'll do a couple of extras here. Look them all over. Which ones do you see that you feel like maybe you would like to practice? 8 through 15. Anybody see any there? 11? 11? All right, so let's
13.
wait. I'm going to do 11. I'm going to do 11, and then I'll do one more. We'll decide what that is in a minute. All right. So here is number 11. There are actually 3 things happening in this problem. Can you tell me what's happening in this problem? It's going up 1. That's actually going to be the last thing I do, but it is going to go up 1 for sure. What else is happening?
-3.
Okay. -3. What's that got to do with anything? What does that negative do?
Flip it over to X.
That's right. So I'm going to say upside down, but yes, it's a flip over the X. What does that 3 do out there in front? Stretch it. It makes it 3 times as tall. This number multiplies the height. So this picture is going to be upside down, 3 times as tall, and moved up 1. Okay? I'm going to do this in stages. It is too much for me. So here we go. I'm going to flip it upside down first. So upside down first. 1, 2, 3, 4. So I'm going to flip it upside down first. So that means that my M is going to come upside down. So if you're having trouble with that, kids, just remember that if you're going over 2 and up 3, you're going to go over 2 and down 3. You're just going opposite direction, vertically. So there's my M, and here's my triangle. Okay, now I'm going to make it 3 times as tall. So that means that, see this point right here? Instead of going up 2, now it has to go up 6. 1, 2, 3, 4, 5, 6. It's coming clear up here. So here is my big tall triangle. And see this point right here? And this one, these 2 points? Instead of going down 3, they're actually going to go down 9. And that one, instead of going down 2, is going to go down 6. Now what? I'm going to get my purple out now. Now what do I need to do? Up 1. So every point is going up just 1. So I'll move everything up 1. And the purple is the answer to the question. So again, it is perfectly okay to do that in stages. Just bring colored pencils or an eraser or something so we know what your final answer is. All right, one more from that page. 12. Now 12 has a double negative in it. So it looks a lot harder than it is. What do negatives always mean? Flips. And since they're both in there, you don't even really need to know which is which. You know, one's, you're going upside down and you're going left to right, right? The order you do it makes absolutely no difference, so it doesn't matter. Flip it one way or the other. So I guess I'll start with a sideways flip. This one's going to go sideways. And this one's going to go upside down. It doesn't matter truly, guys, which way you go. So I'm going to go sideways first, but you can go upside down if you prefer. So sideways first means the M's over here and the triangle's over here. So there's my triangle. I'm just going sideways. And here is my M. So there's my sideways flip. Now I have to go upside down. So this guy's coming down. And this guy's going up. So there they are. That's the answer. It's upside down and flipped sideways. So everybody understands that tomorrow we have a quiz, and I'll probably have, I will have one general weird shape on there, and then you'll have 5 different graphs to do with negatives and numbers and stuff put in. So we got to remember what all the numbers and negatives mean, right? So one more time, a number out in front multiplies the height, multiplies the height. A number out in front. A number inside with the x, like 3x, 2x, 1/5 x, divides the width. And add or subtract outside moves you up or down, and add or subtract inside moves you sideways. A negative on the outside is upside down. A negative on the inside is across Y. Absolute value of the whole thing, bottoms up. Absolute value of just X. Whatever you draw on the right, you reproduce on the left. Got it? Okay. Now, let's get our notes out.